Now I'm going to go through section 3 of worksheet 5, which is speed time graph. So previously you've learned about distance time graph. Now we are learning about speed time graph. So it is another way of presenting a journey graphically where your speed is now the y-axis. Okay, so I'm just going to zoom into this second part of the page here. Okay, so take note, in a speed time graph, the acceleration, known as the rate of change of speed over time, can be determined by the gradient of the straight line at that time. So let me recall, gradient of distance time graph is your speed. Now, gradient of speed time graph is your acceleration. So there is a difference here as to what you're finding for the gradient of each of the graphs. So do take note, gradient of your speed time graph is your acceleration. So from the speed time graph, okay, we can actually know few things. When it is positive gradient, the one I highlighted in yellow, it means that the speed is increasing and the object is then accelerating. Okay, it's going faster. When it's zero gradient, which means horizontal line over here in the blue highlighted part, constant speed. Last but not least, I have a downward sloping line at the end, negative gradient, speed is decreasing, which means the object is decelerating. This means that you'll notice that maybe the object will be slowing down. Okay? So do note there are few units for acceleration. This depends on the units for the speed and the time given in the graph. Also, one more important thing that you have to know, okay, distance traveled is the area under the graph. I will go through a few questions that needs you to calculate the distance traveled of the object. Now let's look at example 3. For examples 1 and 2, please do it on your own and then check the solutions at the end of the video. So for example 3, we are given a speed time graph. Take note, speed here is meter per second and time is in seconds. So for A part 1, we need to find the acceleration during the first 10 seconds, which is this highlighted part in green. So do note, acceleration means it's the gradient of a speed time graph. So what you need to do, you need to find the coordinates of A and B and then calculate the gradient. Okay, to calculate the gradient of AB, you need the coordinates of A and B. Apply the formula and you will get 2. Hence, the acceleration is 2 meter per second square. Do note for the units here, you just need to see speed is meter per second, and then because you're dividing by time, which is in seconds, hence it is meter per second square. Okay, so speed is in meter per second, time is in seconds, so meter per second divided by second, you will get meter per second square. Now let's look at part 2, deceleration during the last 4 seconds. So let me highlight in blue the last 4 seconds, which is the section CD. Okay, we need to find gradient first, then we can find the deceleration. So deceleration here is when the gradient of speed time graph is negative. Okay, so let's find the gradient of CD first and then we can find the deceleration. Okay, after you have found the gradient of CD, which is -5, because deceleration is the gradient of speed time graph being negative, since the gradient is already negative, I can straight away say deceleration is 5 meter per second square. Notice there is no negative sign here. So for deceleration, the word accounts for the negative sign already. So deceleration, you can just write the positive value of the gradient. Now let's go on to part B. Describe the car's motion for the part BC. And if you notice, BC here is a horizontal line. Horizontal line means the gradient is 0, okay? Which means there is 0 acceleration. So the acceleration of the car is 0 meters per second square from the time 10 seconds to 12 seconds. This also means, because if you notice it's a horizontal line, this means the speed from B to C is always constant at 20. Okay, so this is how you explain part B. BC is a horizontal line, gradient is 0, which means acceleration is 0 meter per second square, and the car is moving at a constant speed from 10 to 12 seconds. Now let's look at part D, find the total distance traveled by the car. So total distance to find using speed time graph is the area under the speed time graph. So what do I mean by under? So let's look at the graph here. If you notice, BC, this line, is parallel to AD. So what I can do, since these two are parallel, if you notice, this is a trapezium. Okay, so I recap, area of trapezium is half times sum of parallel sides times your height of the trapezium. So if you notice, my height here is actually 20. And then my parallel side, so for BC, is from 10 to 12. So 12 minus 10 will be 2. And then my other parallel side is from 0 to 16. So this length AD here is 16. Let me write here 16. Okay. So to find part C, it will be half times sum of parallel sides 2 plus 16 times your height, which is 20, and you should get 180 meters. So this is the answer for part C. Now let's move on to part D. Find the average speed. So average speed, let me recap with everyone. Total distance over total time. So total distance, we can use part C's answer. Okay, part C answer, total time, refer to your graph, it is till 16 seconds here. So total distance will be 180 divided by 16. Okay, and you will get an exact value of 11.25 meter per second. Okay, so take note for speed, the units is in meter per second as according to the graph here. For example 4, please pause and try part 1 and part 2 by yourself, and then press play again to see the solution for part 1 and 2 before I go through part 3. Okay, for part 1, just need to note is this green highlighted part, which is a horizontal line. So it is a constant speed throughout, t equals to 30 to t equals to 60. Part 2, find the acceleration for the first 30 seconds highlighted in blue here. Just need to find the gradient and you will get 0.2 meter per second square. Now let's do part 3 together. After 80 seconds, so let me highlight keywords after 80 seconds, which is from here onwards. After 80 seconds, Cheng slowed to a stop with constant deceleration. This means your gradient is negative. Okay, so it should look something like that. Okay, so from this point, it should look like this. It should be a downward sloping line, but I won't draw here because I don't know where to stop on the t-axis. Okay, question gave me another hint. Traveled a further 200 meters, find the value of t when Cheng stopped. Okay, I'm given distance, so do note distance is area under speed time graph. So I already drew a downward sloping line here. Okay, referring to the graph, I know that I need to continue from here. Do note that the height here is 8. So let me write here 8. What about the base? I do know I need to continue from here, which means it's from 80 to a certain value t lah. I don't know what this t is, I need to find. So this is from 80, then t. Okay, if you notice there is a right angle triangle here. This length will be t minus 80. So if you notice, because distance is the area under the speed time graph and the area here is a triangle. So let me just write here, area under graph is equals to the distance, which is 200. It will be the area of the triangle, so half times height times your base, which is t minus 80 equals to 200. Continue on, you'll get 4 times t minus 80. Divide 4 to the right, and then you will get t equals to 130. So this is how you do part 3. I recap again. Starting from the last part of the graph is a downward sloping line because of the word deceleration here. I'm given distance, which is the area under speed time graph. I can form an equation here. Half times height times my base, which is area of triangle, will be equals to 200. You can find the value of t. Do pause here to see the solution for example 1 after you have attempted, and solution for example 2 as well.